Hello, welcome to Math 181 Pre-Calc Tree. This is section 1.4 identities. Starts on page 29. What I've listed here are the reciprocal identities, which means that sine, let me write it correctly, is the reciprocal of the cosecant, and cosecant is the reciprocal of the sine. What do I mean by that? Well, let's take a look. And we'll do it kind of quickly. The sine of theta is equal to 3/5. That means its reciprocal buddy cosecant theta is equal to 5/3. It's just simply the reciprocal. This is kind of a fancy way of writing it out. If the cosine of, well, let's do it backwards. If the secant of theta is equal to 3/2, then the cosine of theta is equal to 2/3. So sine and cosecant are reciprocal functions. In other words, their answers are upside down. Cosine and secant, same thing, we invert them. Tangent and cotangent. Those are what we call reciprocal functions. Cotangent with tangent, tangent with cotangent. Let's try another one here and see if we can figure it out. I'm going to clean these off the screen. And let's take a look. Here I want to find the sine of theta. And they gave me that the information they gave me was that cosecant of theta is equal to negative radical 12 over 2. And I want to write the sine. So the sine of theta would simply be, I'm going to scoot this over a little bit here. Sine of theta would be the reciprocal of this, which is still going to be negative. If the number is negative, its reciprocal is negative 2 over radical 12. But I want to simplify radical 12. So this would be negative 2 over square root of 4 times 3. 4 comes out as a 2. So it's negative 2 over 2 radical 3. These cancel. So now I have negative 1 over radical 3. But I want to rationalize that. So I'm going to multiply the top and the bottom by radical 3. We want them in a form where the denominator, in this case this would be the square root of 9, which is 3, is a whole number. And so this would be my solution. A little bit more complicated than maybe we had hoped for. So another one, here's what the first one they gave us, secant theta equals 5/3. We don't have to be real fancy. You don't have to put 1 over that or anything. You just know that the secant and the cosine are reciprocal buddies, we're called, and this is 3/5. And that's it. It's just the reciprocal. All right. Anything else that's exciting here? All right. Well, the other thing is we talked about last time was the quadrants. First quadrant, second quadrant, third quadrant, fourth. And I gave you an old saying here, all students take calculus. And what that means is that in the first quadrant, we're kind of looking for positive answers, positive functions. In the first quadrant, they're all positive. In the second quadrant, S stands for sine. The sine of theta will be positive, and its reciprocal buddy, the cosecant, will be of theta. These will both be positive. Okay, in the third quadrant, T stands for tangent and cotangent. And in that quadrant, those are the only two that are positive. All the other functions are negative. Same thing here. The only two that are positive, sine theta, cosecant theta. What do you think C stands for? Cosine theta. Cosine theta and secant theta are reciprocal buddies, and they're the only two that are positive in that quadrant. So the only ones that are positive, all of them in first, sine, cosecant, tangent, cotangent, cosine, secant. So let's take a little practice here. Sine theta, cosine theta, tangent theta, cotangent theta, secant theta, and cosecant theta. And we're going to make some columns here. I'm not too good at drawing these columns. Try the best I can. Pretty decent. Okay, let's draw a line here. Okay, let me take a look at some angles. And this is example 2 in your book on page 30. So EX2. And in this quadrant, first of all, they gave us 87. Well, let's look at 87. 87 degrees is between 0 and 90. So it's in the first quadrant. This is the initial side. This is the terminal side. The angle is counterclockwise. And that's theta right there. So in this case, this is 87 degrees. That's what theta equals. And we know that all the functions in this quadrant, I'll put an A, are positive. So we just put all plus signs. We're trying to determine which ones are positive and which ones are negative. Okay, let's look at the angle 300. 300 degrees. Well, what would 300 degrees look like? Let's draw a little grid here. Here's 0, 90, 180, 270. So 300 is going to be in this. Here's your initial side, but we're going to go counterclockwise. Oops, there. And here's our terminal side right here. So this is our angle. This is 300 degrees. It's the outside angle. Okay. If we went this way, it would be negative, but we have a positive answer. So 300 is going to be between 270 and 0 and 360 being the same thing. So let's take a look at our angle right here. All students take calculus. Only the cosine and its buddy secant are going to be positive. So let's put a plus sign there. Let's find the secant because these two are reciprocal functions. Okay. Now what we're going to do is put negative signs for all the rest. Okay, the last one according to the book, negative 200. Negative 200. Well, again, let's take a look at what is negative 200 like. Sorry, let's get this all out of here. Negative 200 degrees. Well, a positive 360 plus a negative 200, I guess it was, is 160 degrees. So our angle is going to be between 0 and 180 right here. So our angle is right in here. Again, initial, terminal. Now, if I want to draw the other angle, always project onto the x-axis, never to the y. This is your y-axis. This is your x-axis. So we always project to the x-axis if we want to make a right triangle. Okay. So this is your initial, terminal. So how are we going to do this? Well, a positive 360 and a negative 200 gave us the 160. I'm sorry, I already did that. And so now I'm going to look at 160. 160 is this angle right here. It's in the second quadrant. All students. Sine, positive. Its reciprocal buddy, cosecant, positive. All the rest, negative. Okay, just that easy. All right, let's try another little hunt here. On this problem, it says, this is example 3. It says, identify the quadrant or possible quadrants of an angle theta that satisfies the given conditions. Sine theta is greater than 0. Tangent theta is less than 0. So what are they saying? Well, sine theta is a number that's bigger than 0. Numbers that are bigger than 0 are positive. It's telling me that the sine is going to be a positive number. And the tangent is less than 0, telling me that it's a negative. So in which quadrant would the tangent be negative and the sine be positive? Let's take a look. 1, all. 2. Well, we know the sine is positive here. But what about the tangent? Well, the tangent is negative, huh? Only the sine is positive. What about in the third quadrant? All students take. The tangent is positive and the sine is negative, but that's not what we want. We want this to be positive and this to be negative. Okay, what about the last one? Well, quadrant 4, all students take calculus, cosine. Cosine is the only one positive, so neither of these are going to be positive in that quadrant. So it looks like it has to be quadrant number 2. All right, let's look at the next problem. This one, it says the cosine of theta is less than 0, which we know is going to be negative. And the secant of theta is less than 0, which is negative. So it couldn't be in the first quadrant because they're all positive. What about in the second quadrant? Yes, the cosine is negative, and its buddy secant is also negative. So that one could be in the second quadrant. What about the third? Well, yes, the cosine is negative, and the secant is also negative. Only the tangent and cotangent are positive. So this is in the third quadrant too. So there's 2 quadrants it could be in, second and third. So that's how that's done. It's kind of a nifty little thing. Page 31, just ignore all the other junk on that page. Okay, example number 4, we're trying to figure out functions. And this will come in handy. This you'll probably figure out when you get a calculator. But the cosine and theta are numbers that are smaller than 1, or -1, or larger than -1. They could be 0.99999 or something like that. But that's as high as they can. They're going to be a decimal with no number in front. So they would be like 0.987 or something like that, 0.321. Okay. So the way we describe it is they could also be negative. So from -1 to 1, they're going to be in that category. Okay, what about the tangent? Tangent and its buddy, the cotangent. Those 2 guys, they're going to be any number of work. So from -infinity to infinity, it's all going to be good. And the reciprocals of these, the cosecant theta and the secant theta, those 2 are going to be large numbers. They have to be numbers. They can't be something as small as 0.23. It's going to be a number 1 or bigger, okay? So they're going to be large numbers. They could possibly be negative, but they're going to be very large numbers. So if it's anything, it's just the opposite of this. It's anything from -infinity to 1, negative 1, I should put, and then from 1 to infinity. Nothing in between. I guess that's a. So from 1 to infinity. So there'll be large numbers. These are large. These could be any number, and these are small. Okay, so just to take a quick look, what if they told us that the sine of theta equal to 2.5? Way too big. If they said 0.5, good. This is no. Even if it was negative, that still would be no. It can only be a decimal, something like that. Okay, on the next one, it says tangent theta equals 110.47. Yeah, that's good. Any real number. It could be any real number. This is yes. Okay, what if they said the secant of theta was 0.6? No, that's too small. They have to be a number usually greater than 1, or a small number going in a negative direction, like -2, -3, or something like that. So this is definitely out. No, if they had said 2.6, then it would have been okay. Okay, example 3, we're going to do a little hunting again. We're going to find an angle theta in the second quadrant. And the sine of theta is going to be equal to 2/3. And we want to find the other angles, the missing angles. Well, what do we know about the sine of theta? Well, we know the sine of theta equals the value of y over the value of r. So let's graph this and see what that looks like. We're saying r is 3 and y is 2. So 1, 2, and then it's shooting out here like 3 units. But remember, we don't go we always go down. So this would be 2 going down. This is your y direction, and this is your r direction. R is your hypotenuse, right? This is your right triangle. The angle we're looking at, let me write this out. The angle we're looking at is this angle right here, outside the triangle. So what we want to find is x. And we also know that x is going in a negative direction. So we know that x has to be negative. Okay? We know the sine function was positive. That doesn't mean that the x itself is going to be negative. So how are we going to do this? Well, sounds hard, huh? But we have a little relationship here. R squared equals x squared plus y squared. Is that the Pythagorean theorem? Very nice, huh? So if we move this y squared to the other side, do a little rewriting, we can find that x squared equals r squared, which is the longest side, minus the shorter side, y squared. And if we want to find x, well, then it would be the square root of that. Let's just find x squared first, and then we'll worry about it. Okay, so what we're going to do is for r, we're going to substitute 3 and square it. And for y, we're going to substitute 2 and square it. And so x squared is 9 minus 4. X squared is 5. And if we take the square root of both sides, x is square root of 5. But remember, square roots can come plus or minus. And in this case, we want the minus value. So it's negative square root of 5. Okay, so I'm going to put that in my little drawing here. So now we know what x is. So now let's define our angles. Sine theta equals 2/3. Easy, huh? Let's use the reciprocal function. Cosecant theta equals 3/2. Cosine theta what is cosine theta? Cosine theta is x over r. Just jot it here. X over r. X is negative square root of 5 over r, 3. So that's what x is. Cosine is negative square root of 5 over 3. And so what would the secant be? Secant would be, if this is negative, its reciprocal is going to be negative 3 over radical 5. We don't want to leave that answer, so let's rationalize it. 3 radical 5 multiplied by radical 5. Sorry, 3 radical 5 over radical 25, which is 5. So we want to simplify that to 3 radical 5 over 5, and we want to keep it negative. Okay, what about the tangent? The tangent of theta. Tangent of theta, what is that equal to? Y over x, huh? So y would be 2, and x is 2 over negative square root of 5. So again, we have to rationalize. Let's bring up the negative sign to the top, and let's rationalize that. So 2 radical 5, radical 5, radical 5. Looks like it's going to be negative 2 radical 5 over the square root of 25, which is 5. And what about the cotangent theta? Well, this would be this upside down. It's still going to be negative radical 5 over 2. So only when the radical's in the denominator do you have to kind of worry about it. So that's how you would go about it. And a lot of times that's how you can do it. Okay, now we're going to introduce a couple more ideas to this. We're going to introduce what we call the Pythagorean identities. Pythagorean identities are very useful in math. We use them all the time. Okay, so let's look at this Pythagorean identities. The one we probably use the most is this one, sine squared theta. I don't know whether they're derived from the Pythagorean theorem, but I didn't bother deriving them. You're going to have to take my word for them. Equals 1. So sine squared theta plus cosine squared theta equals 1. But we can also do variations on this. For instance, say I want to find the cosine squared theta. Then all I got to do is bring over the sine to the other side, 1 minus sine squared theta. I can just take that over there, see. So, we might have to change the form. Or sine squared theta would equal what? 1 minus what? Cosine squared theta. There you go. So these are variations on it.